A few weeks ago, we looked at multiplying whole numbers, and we looked at some different models of ways we could represent those multiplication problems. What I want to do real quick is I want us to look through a few of those models, and then we're going to move into multiplying decimals using those same models, those same representations. Looking at the problem 5 times 3, I can represent this problem using some different models. One model I can use is equal groups. So I could draw 3 equal groups, and I could put 5 in each group. And that equals a total of 15. I could also use a number line or use skip counting. So I could count by fives, and I can skip 3 times. So I'm going to count by fives 1 time, 2 times, 3 times, with for an answer of 15. I could draw an array where I have 5 on this side, and I have 3 on this side, and I would have a product of 15. We could do standard algorithm. We could say 5 times 3 is 15. And we can even look at the fact families for this. We could say 5 times 3 is 15. 3 times 5 is 15. And then I could do the opposite operation. I could do 15 divided by 3 equals 5. And 15 divided by 5 equals 3. Now in these examples, I'm using 2 whole numbers, but we can use all of these same models looking at decimals as well. Look at this example with me. We're going to be looking at the problem 5 times 4 tenths. And we're going to use those same representations that we just used with whole numbers, but this time we're going to use it with a whole number and a decimal that's less than 1. So let's think about our equal groups model. Now I know that I can make 5 groups. 1, 2, 3, 4, 5. And I want to put 4 tenths in each group. Now in this case, I'm going to use a long or a tens piece that we use with our place value blocks, but these 10 sticks are going to represent our tenths now. So here in our model, I'm going to put 4 tenths in each group, 4 tenths in each of 5 groups. And now let's count how many tenths I have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I have 20 tenths, which I also know is equal to 2 wholes. Now I can also do skip counting. So I want to skip 5 times, and each time I'm going to skip 4 tenths. So I'm going to start at my 0. I'm going to hop 4 tenths. So looking at this number line, I hopped 4 tenths on this number line. 1, 2, 3, 4 tenths. And each time was 4 tenths. And I hopped 1, 2, 3, 4, 5 times. So 5 times, and each hop was 4 tenths. And now let's look at an array. An array is going to be really similar to our equal groups model. We're going to want to make 5 groups with 4 tenths in each group. So I'm going to use 5 different colors, and I'm going to shade in 4 tenths each time. So here's 1 tenth, 2 tenths, 3 tenths, 4 tenths. I'm going to grab a different color. There's one group. Now let's do 2 groups. 1 tenth, 2 tenths, 3 tenths, 4/10. Now let's grab another color. Let's do 4 more tenths. 1/10, 2/10, 3/10, 4/10. Let's grab another color and let's do 4 more. 1, 2, 3, 4/10. And we need one more group of 4/10. So 1, 2, 3, 4/10. So here is my one group, two groups, three groups, four groups, and 5 groups of 4/10. And in all, I have one hole here, and here is my 2 holes. So when I shade in 5 groups with 4/10 in each group, that equals 2 holes. Now, on standard algorithm, we've looked at our models here. We've looked at our equal groups model, and we said that it equaled 20/10, which is 2 holes. We looked at our skip counting. We jumped 5 times with 4/10 in each jump. We landed on 2. Our array, we made 5 groups with 4/10 in each group. So for our standard algorithm now, we can say that 5 times 4/10 equals 2 holes. So when I look at my fact family, then what I'm going to do is I can say 5 times 4/10 equals 2 holes. 4/10 times 5 equals 2 holes. Now I can use the inverse operation, and I can say 2 holes divided into 5 groups equals 4/10. And then I can say 2 holes divided into 4/10 in each group equals 5 groups. So the example we just did was multiplying a whole number times a decimal less than 1, where the decimal was in the tenths place. This example now, we're going to multiply a whole number times a decimal where the number's in the hundredths place. So on the previous example, when we talked about tenths, we used the tens rods and our place value blocks to represent the tenths. So for the hundredths now, we're going to use the unit cubes to represent the hundredths. So what we normally represent when we're talking about whole numbers, we represent the ones place. That now is going to represent my hundredths place. And then my whole numbers are represented as the flat. So we're kind of using some different thinking now with our place value and using our place value blocks. So let's think about the problem now. 8 times 6 hundredths. So again, I want to make 8 groups. So here is my 8 groups, and I know that I want to put 6 hundredths in each group. So I'm going to use my little hundredths representation using that little unit cube, and I'm going to put 6 hundredths in each group. So I have 6 hundredths in each of my 8 groups. So we know that 6 times 8 is 48, and we know we're counting our hundredths. So 48 hundredths written as a decimal would be 48 hundredths. Now let's look at the skip counting. I'm going to do the same thing I did earlier, except for this time I'm going to hop 6 hundredths each time, and I'm going to hop a total of 8 times. So I hopped 8 times, and each time I hopped 6 hundredths. So there's 1, 2, 3, 4, 5, 6, 7, 8. And each time I hopped 600. So each little hop right here represents 600ths. I hopped 8 times and I hopped 600ths each time. So I landed on 4800ths. Now let's look at our array model. It's going to be real similar to our equal groups model again. We want to shade in 600ths and we want to do that 8 times. So here goes one group of 6. Here goes 2 groups of 6. 3 groups of 6. 4 groups of 6. 5 groups of 6. 6 groups of 6. 7 groups of 6. And 8 groups of 6. So if I counted up all of those hundredths that I just shaded in, I shaded 48 hundredths. Now for standard algorithm, we have said that 6 hundredths times 8 groups is 48 hundredths. And in the problem you might notice where the decimal places are. In 6 hundredths, I have 2 decimal places. And in my answer, I also have 2 decimal places. So I want you to kind of keep that in mind because next week we're going to be looking more at standard algorithm and looking at our decimal places. So finally, let's put our fact family together. So we have 6 hundredths times 8 groups equals 48 hundredths. 8 groups times 6 hundredths in each group equals 48 hundredths. I can do the inverse operation now. I can say 48 hundredths divided by 8 groups equals 6 hundredths in each group. And I can also say 48 hundredths divided into groups of 6 hundredths equals 8 groups. So these are some different representations that we can use when we are multiplying a whole number by a decimal less than 1. Now what I'd like for you to do is I would like for you to add this into your journal. So if you guys will pause the video for a minute and get journals passed out and get your tape out, we will restart the video when you guys are ready to add it to our journals. Okay, so in your table of contents, today is October 11th. Okay, I'm not sure which entry this is, but whatever next entry it is, please put that number there. And then the entry title is going to be multiplying whole number times a decimal. Multiplying a whole number times a decimal. And then go ahead on your page number and write the next page number. And then I want you to go ahead and turn over to that page number, and then you will add this into your journal. Go ahead and tape it in for me.